gonna do a little bit of background maths on this question. Like you're watching this video, you might not have seen a question like this before. So you can skip on if you have seen things like this, and maybe we'll get straight into the actual problem itself. But this is like a next level version of a particular topic. So I'm going to first of all look at a simpler problem. What happens when I just have a number on the top? And I might be interested in all the different values of x that would give me an integer solution for 6 over x plus 1. And so what we actually do, our approach is to look at the factors of 6, because if I'm dividing by a factor of 6, I'm going to get a whole number. So 6 would work, and 3 would work, and 2 would work, and 1 would work. But actually, -6 would also work. There's nothing saying it has to be positive, and -3, and -2, and -1. So there'd actually be 8 different possibilities. I haven't quite got space for it, and I'm just illustrating the idea. But then if I want to find my values for x, I just need to -1. So I'd get 5, 2, 1, 0 is okay for x, and then -7, and so on. And these would be my answers. Now, there's a second type of question. So that's how you deal with that sort of question. There's a second type of question that you get, and it's when you might get like an X on top. Okay, and this makes things a little bit more difficult. But there's a nice approach that you can take. You can actually, we want to try and cancel out, because at the moment it's actually quite hard, because if you suddenly start putting like a factor of 6 in, well, it's going to sort of affect it. And there's right, ideally, no, not ideally, the method is to get rid of that x. And we can do this by actually doing the following. We can do 6x plus 6 minus 6. So I'm not actually changing the fraction over x plus 1. And then I'm going to rewrite it as 6x plus 6 over x plus 1 minus 6 over x plus 1. So I've separated it into two fractions. Now here I can either factorize, so it's 6x plus 1 over x plus 1, or I can just sort of see that I can cancel it down. I'm going to get 6 here. And I've actually managed to turn it into exactly the same problem as the first one, because now I'm interested in integer solutions. This will have exactly the same number of integer solutions as the one above. Okay, I purposely chose this example to turn it into that problem. It might not be 6 over x plus 1. It all depends on what's up here. So yeah, but it illustrates the idea. So we're going to use that idea on this question here, except this one's a little bit more difficult, because it was okay when I just had an x, but now I've got 7n plus 12, and the idea was to somehow cancel it down, like somehow cancel the x part down. But I've got 7n plus 12 and 2n plus 3. So using the idea that I've illustrated here, actually the approach is I want to somehow get 2n plus 3 and factorize out some sort of number. And the only number that's going to work is 7 over 2. That will work. I might just stick with the decimal at the moment. So 3.5. So that will give me 7n plus 10.5. So I'm also going to need 1.5 here. I just found it a bit easier to deal with the decimals and the fractions, but I'm actually going to bring the fractions back in. All over 2n plus 3. So now I can write that as 3.5 2n plus 3 over 2n plus 3 plus 1.5 over 2n plus 3. These cancel out, and I'm actually left with 7 over 2 plus, it's actually going to be a half times 3 over 2n plus 3. I've kind of taken a half out. I could write this as 3 over 2, and then I could bring the half out. And ultimately, I can factorize out the half. This is what makes this like a little bit trickier than the ones on the right. So it's going to be 7 plus 3 over 2n plus 3. Okay, and actually, this is the one I'm dealing with. Now, before we carry on with this question, if you don't like that method, you might be happier with polynomial division, which is absolutely fine to use. It's going to be 2n plus 3s into, what did we have? I've already forgotten, 7n plus 12. And I'm going to get the same thing again. I'm going to do 7n divided by 2n, which gives 3.5. Multiply back through 7n plus 10.5. You can say the same numbers coming up. We're going to be left with 1.5. And that would leave me with my quotient of 3.5 and then my remainder of 1.5, which would be 3.5 plus 1.5 over 2m plus 3. And I would then have to, do the same sort of steps to get to here. Okay, I've spent quite a lot of time talking about how to get to that point, but it's important, especially if you've never seen it before. And now I'm going to talk about how to actually solve this to find all the integer values. Now this factor of a half is what makes, sorry, I'm good. Like, remember, I'm up to here. This is my key thing that I'm talking about. So basically I've got this half in there. So I require the, not just the integer solutions, but the even solutions to 7 plus 3 over 2m plus 3. Because if that was odd, then I'd be dividing an odd number by 2. I'm not going to get an integer. And how do I get an even number here? Well, I'm going to need this to be odd. Find odd. When I say solutions, I mean the odd values of 3 over 2m plus 3. Remember, n has to be an integer. It can't be like a half or anything like that. Okay, so what I'm actually going to do is I'm going to do the same sort of approach previously, and then we'll just worry about if it's odd afterwards. So 2n plus 3. Right. I'm just trying to set it up in the same sort of way I did before. So 2n plus 3. Okay, one possibility would be for it to equal 3. Actually, I might as well see if it's going to be odd as I go along, because then I'd be doing 3 divided by 3. That will give me an odd value. It'll give me 1. And then if I do minus 3, that will also work. I'll then get minus 1. That will be odd. Brilliant. And then if I do another factor of 3 is 1, that would be 3 divided by 1, which is odd. So that's going to be okay. And then minus 1. So actually, all of these solutions will be okay. And I'll get minus 3. So I've forgotten what I'm actually trying to find. What is the sum of all such integer values of this expression? Okay, so actually, I don't even need to find n, technically. I can actually get to the solution from here. I think I'm just going to finish it off, though, because you might another time be asked to find the values of n, so it's important to do that. So to find 2n, I'm just going to minus 3 from all the values. I'm going to get 0, minus 6, minus 2, and minus 4. And then to get the values of n, I'm going to get 0, minus 3, minus 1, and minus 2. So these would be my solutions for n for this problem. That would give me an integer value of 7m plus 12 over 2m plus 3. Okay, but remember, that's not actually what we're being asked for. We're asked to find the sum of all the integer values of this thing here. This half times 7 plus 3 over 2m plus 3. And it probably would have been helpful to then write down like what, let me do it up here. What is 3? I've established that all of these are okay. So what is 3 over 2m plus 3 in these different situations? It's going to be 1 minus 1, 3, and minus 3. Okay, so let's find out these values. So when n is equal to 0, I'm going to get a half times 7 plus 1, which is going to equal 4. When n is equal to minus 3, I'm going to get a half times 7 minus 1. I'm just putting each of these in because that is my 3 over 2m plus 3, and that's going to be 3. When n is equal to minus 1, it's going to be a half times 7 plus 3, which is 5. Then my last one, when n is equal to minus 2, I'm going to get a half, 7 minus 3. You can see they're all working out. I'm going to get 2. And the sum of this is going to be 7 plus 7. So the answer is 14. Okay, well done on this question. Like if you attempted it, really nice and like, a good extended version of this sort of problem. You might want to find out, some more to try, especially if that is the first time you've ever seen this. But yeah, keep practicing and well done.